The universe is already dead. We are just waiting for the notification to arrive. Everything you see in the night sky, every streak of starlight, and every majestic galaxy is merely a brief, almost instantaneous exception to the rule. We are accustomed to thinking of the cosmos as a perpetual motion machine filled with energy and light. But the truth is that we were born in an abnormally bright, abnormally active, and terrifyingly short moment. We live in the golden age of the universe, a time when matter is still young, gravity is still creative, and time feels like something that works in our favor. But this celebration of life is just the short flicker of a match in an infinitely long, cold hallway. If we try to compress the entire history of the existence of the universe into a single calendar year, the entire era of stars in which we are lucky enough to exist would end in the very first second of the 1st of January. For the rest of the year, for the other 364 days, 23 hours, and 59 minutes, the universe will exist in absolute darkness and cold, the likes of which we are afraid to even conceive. What we perceive as reality is a cosmic fluke, a temporary byproduct of a young universe that is still in the process of cooling down. The light of the stars is not the default state of the cosmos. It is a frantic, short-lived resistance against the inevitable, encroaching darkness. The history of the future begins with a slow, agonizing dimming that will span trillions upon trillions of years. We currently live in what astronomers call the stelliferous era, the age of stars. It is a time of abundance where vast clouds of gas collapse under their own weight to form new suns, which in turn give rise to planets, moons, and life. But the supply of hydrogen, the primary fuel of this grand engine, is finite. Eventually, the cosmic factories will run out of raw materials. In about 100 trillion years, the last star will be born. The universe will stop creating light and start consuming what remains. The great cosmic stage will not go dark all at once. Instead, the lights will begin to go out one by one, starting with the most massive and brilliant. The high-mass blue giants, those magnificent stars that burn with the intensity of a million suns, will be the first to vanish. They burn through their fuel in a few million years, leaving behind supernova remnants or black holes. Then the yellow suns, stars like our own, will fade into white dwarfs. Eventually, only the red dwarfs will remain. These are small, dim, and incredibly frugal stars that can sip their hydrogen for trillions of years. But even their time is limited. When the last red dwarf flickers and dies, the universe will enter the degenerate era, a phase of existence where the very concept of a star will be nothing more than a ghost of the distant past. In this deep twilight of reality, the cosmos will be populated only by the remnants of what once was. White dwarfs, neutron stars, and black holes will be the only inhabitants of a dark and expanding void. A white dwarf is a diamond-like sphere the size of Earth, but with the mass of a sun, a glowing ember left over from the death of a star. For quadrillions of years, these embers will slowly cool, radiating their remaining heat into the abyss. They will transition from white to yellow, then to red, and finally, they will become black dwarfs. A black dwarf is a hypothetical object, a star that has cooled so much that it no longer emits visible light or heat. It is a cold, dark, solid sphere of carbon and oxygen, drifting in total darkness. Because the time required for a white dwarf to cool into a black dwarf is significantly longer than the current age of the universe, there is not a single black dwarf in existence today. We are living so early in the story that the first true corpses of stars have not even had time to turn cold. They are still warm to the touch of our telescopes, still clinging to the memories of the fires that created them. But as decillions of years pass, the heat will bleed away, and the universe will become a cemetery of frozen, lightless stones. As the universe continues its relentless expansion, Driven by the mysterious force of dark energy, the distances between these stellar remnants will become so vast that even light will not be able to bridge the gap. Space itself will stretch faster than any signal can travel. Every black dwarf, every neutron star, and every black hole will be isolated in its own private observable universe, surrounded by nothing but a growing, absolute vacuum. The galaxies themselves will dissolve as gravitational bonds weaken and individual stars are flung out into the intergalactic void. It is here, in this era of isolation, that the most powerful objects in the universe will take center stage. Black holes, once the terrors of the galactic centers, will become the final guardians of matter. For a period of time so long that numbers lose their meaning, black holes will be the only things that happen in the universe. They will slowly grow by swallowing the stray particles that occasionally cross their event horizons, but eventually, even they must face the laws of thermodynamics. According to the laws of quantum mechanics, specifically the theory of Hawking radiation, black holes are not truly black. They slowly, almost imperceptibly, leak particles back into space. This process is a consequence of virtual particle pairs appearing near the event horizon. If one particle falls in while the other escapes, the black hole loses a tiny fraction of its mass. For a black hole with the mass of our Sun, it would take 10 to the power of 67 years to evaporate. For the supermassive black holes at the hearts of galaxies, it could take 10 to the power of 100 years. This is a number so large that if you filled the entire visible universe with fine sand, the total number of grains would still be an insignificant fraction of that time. But in the stillness of the far future, even this unimaginable duration will pass. As a black hole loses mass, it gets hotter and evaporates faster. In its final seconds, a black hole will release all its remaining energy in a massive pop, a brief flash of gamma rays and high-energy particles. These will be the last major events of the era, the final pops of the cosmic bubble wrap, until the last black hole vanishes into the vacuum, leaving behind nothing but a thin, cold soup of subatomic particles and low-energy radiation. The universe will appear to be reaching its final frozen breath, but matter has one last, strange secret to reveal. If the proton is stable and does not decay over time, as some grand unified theories suggest, then the black dwarfs will not simply drift forever in an unchanging state. On timescales that dwarf everything we have discussed so far, a strange phenomenon called quantum tunneling begins to dominate the behavior of matter. In our everyday world, atoms are locked in place by energy barriers. To fuse two nuclei together, you need the crushing pressure and searing heat of a star's core to overcome the electromagnetic repulsion. But in the quantum world, there is always a tiny, non-zero chance that a particle can simply appear on the other side of a barrier, as if it had tunneled through a mountain instead of climbing over it. It is a process of pure probability, a manifestation of the wave-like nature of matter. Over a period of 10 to the power of 1,500 years, this process of cold fusion will slowly transform the composition of the black dwarfs. One by one, the atoms of carbon, oxygen, and neon will tunnel into each other, fusing into heavier and heavier elements. This is not the violent, energetic fusion of a young star. It is a slow, ghostly transition occurring in the heart of a frozen, lightless sphere. It is a process of nuclear stability seeking its lowest possible state. The end point of this process is iron. Iron-56 is the most stable atomic nucleus in the universe. It is the bottom of the energy well. Once an atom becomes iron, it can no longer release energy through fusion or fission without an external input of immense power. Iron is the ultimate ash of the cosmos, the final resting place of nuclear chemistry. The universe will slowly turn into a graveyard of iron stars. These are not stars in the sense that we understand them. They are not balls of incandescent gas, but solid metallic spheres of pure iron. They will be cold, gray, and perfectly smooth, reflecting no light because there is no light left to reflect. They are the final form of matter, the ultimate state of order in a universe that has otherwise descended into total disorder. They will drift in a void so empty that each iron star will be the only object in an area of space, billions of trillions of times larger than the current observable universe. They are the monuments of an era that has forgotten the meaning of heat, light, and life. An observer, if one could exist, would see nothing but a black star in a black sky, a ghost of a sun made of solid metal. These objects represent the final triumph of gravity and nuclear stability over the chaos of the early universe. They are the end of the road for the periodic table. But even these iron monuments have an expiration date. There is a final act in the play of the universe, a last explosion before the silence becomes truly permanent and the darkness becomes absolute. If the iron stars are heavy enough, specifically if they exceed what is known as the Chandrasekhar limit, they will face a final reckoning. This limit, roughly 1.44 times the mass of our Sun, is the threshold beyond which electron degeneracy pressure can no longer hold an object up against its own gravity. Over even longer timescales, through a process known as picano-nuclear fusion, the iron star will eventually reach a tipping point where its density becomes so great that its own structure begins to fail. The entire metallic sphere, the mass of a sun compressed into the size of Earth, will suddenly and catastrophically collapse in on itself. This will be the iron star supernova. It will be an explosion of incredible violence and brightness, occurring in a universe that has been pitch black for decillions of years. It will be the loneliest firework in history. There will be no one to see it, no planets to be scorched by its radiation, and no gas clouds to be sparked into new life by its shockwave. It will be a final desperate protest against the encroaching darkness, a single brilliant flash of light in a desert of time that has lasted for 10 to the power of 32,000 years. This duration is so immense that our minds cannot create a metaphor for it. It is a time scale where the entire history of humanity, from the first stone tool to the last star, is a negligible flicker. After this final supernova, the iron star will collapse into a black hole, which will then slowly evaporate through Hawking radiation, leaving behind nothing but the vacuum. This is the cycle of the future, matter turning to iron turning to light, and light turning to nothing. When the last iron star has exploded and the last black hole has vanished, the universe will finally reach its true end. This is the state of heat death, or the Big Freeze. The temperature of the entire universe will be a fraction of a degree above absolute zero. The expansion of space will have pushed every particle so far apart that they can no longer interact. Every photon will be redshifted to the point of zero energy. Time will lose its meaning because nothing will ever happen again. There will be no way to distinguish the past from the future because there will be no change, no events, and no flow of energy. The universe will be a cold, dark, and empty void that will exist for an infinite amount of time. It is the ultimate state of entropy, the final stillness. The fact that we are here right now, in this particular moment, to discuss the end of time is a mathematical miracle. We are living in a tiny sliver of cosmic history that is uniquely suited for life, complexity, and consciousness. We are the way the universe looks at itself before it closes its eyes forever. Every star we see, every breath we take, and every thought we have is part of a magnificent, fragile flash of lightning in a perpetual night. We are not the main story of the universe. We are the fleeting prologue, a short-lived chemical accident that occurred while the cosmos was still hot enough to permit it. Our era is a beautiful, bright anomaly in a story that is mostly about darkness, iron, and silence. We are the temporary inhabitants of a grand house that is slowly burning down. Understanding the era of iron stars is not an exercise in nihilism, but a call to deep appreciation. It highlights the incredible value of the present moment and the rarity of the conditions we take for granted. We live in a time when the sky is full of galaxies, when energy is abundant, and when the laws of physics allow for the existence of something as complex as a human being. We are the witnesses of the light, the only ones who can record the beauty of the stelliferous era before it passes away. We have a duty to observe, to learn, and to experience as much as we can, because we are the only ones who will ever be here to see it. We are the cosmic eyes that will soon be closed. The iron stars are a reminder that everything we know is temporary. The mountains, the oceans, the earth itself, and even the sun are just temporary arrangements of matter that will eventually be processed through the cold machinery of time into iron and then into nothingness. But the transience of these things does not make them meaningless. On the contrary, it makes them infinitely precious. We are the inhabitants of the golden hour, the brief period of dawn before the long winter of the cosmos sets in. The fleeting nature of our world is what gives it its beauty. If the stars were eternal, their light would be cheap. Because they are dying, they are priceless. We are part of a rare window of opportunity where the universe woke up and realized it existed. As we look up at the stars tonight, we should remember that we are seeing something that will one day be considered an ancient legend, if there were anyone left to remember it. We are seeing the fuel that will one day become the iron stars. We are part of a grand transition, a journey from a hot, dense point of infinite potential to a cold, vast void of absolute silence. And in the middle of that journey, for a single glorious second, there was us. We were the spark that defied the dark. We were the consciousness that asked why. And though the iron stars are the inevitable end, they cannot take away the fact that for a moment the universe was alive, and it was beautiful. The memory of this light will be etched into the very structure of space-time, even if there is no mind left to recall it. So do not fear the darkness of the far future. Do not be overwhelmed by the scales of time that make our lives seem like nothing. Instead, realize that you are part of the most interesting part of the entire story. You are living during the cosmic climax, the moment of peak complexity and activity. Beyond the era of iron stars lies a silence that no sound will ever break, and a darkness that no light will ever pierce. But right now, the universe is screaming with energy, and the light is everywhere. We are the eyes of the cosmos, and our vision is a gift. Let us look at the stars with the knowledge that they are a rare and wondrous sight, a temporary reprieve from the iron fate that awaits all things. We are the children of the light, and this is our time to shine. To contemplate the iron stars is to accept our place in the cosmic hierarchy. We are small, we are brief, and we are destined to fade. But in our brevity, we are capable of understanding the infinite. We can calculate the death of stars that have not yet been born. We can predict the behavior of matter decillions of years into the future. This ability to comprehend the scale of our own obsolescence is perhaps the greatest achievement of the human spirit. We are the only part of the universe that knows it is going to end, and yet we continue to build, to love, and to explore. We are the defiance of the void. The iron stars will eventually collapse and vanish, and the universe will become as it was in the beginning, empty and silent. But the history of the stars, the history of life, and the history of our own thoughts will have happened. The void cannot take that away. The existence of the stelliferous era is a permanent fact of the universe, even if it is a short one. We are the architects of meaning in a universe that has none on its own. We are the storytellers of the cosmos. And though the final chapter is written in iron and shadow, the early chapters were written in fire and light. That is our legacy, and it is a legacy worth celebrating. As we move forward into our own uncertain future, we should carry the perspective of the iron stars with us. It puts our daily struggles into a different light. The conflicts of nations, the pursuit of wealth, and the fears of the unknown are all insignificant when viewed against the backdrop of 10 to the power of 32,000 years. What matters is that we are here now, and that we have the chance to make this brief moment as bright as possible. We are the stewards of the only light in a universe that is mostly dark. Let us use that light well. Let us be the ones who dared to look into the abyss and see not just the end, but the incredible beauty of the journey. The era of iron stars is the inevitable destination of all matter, but it is not the meaning of the universe. The meaning is the process, the transition, and the conscious experience of the journey. We are the travelers of the golden age, and our footprints are made of starlight. Though they will eventually be covered by the iron dust of eternity, they were here. We were here. And for a moment, the universe knew itself. That is the triumph of the light. That is the secret of the iron stars. That is why we continue to look up, to wonder, and to hope, even in the face of an infinite and lightless future. We are the universe's dream of life, and we must dream it as vividly as we can while the stars still burn. Eventually, even the iron will be gone. Even the iron stars will succumb to the expansion of space or the decay of the vacuum. The final state of the universe is one of absolute simplicity, a return to the void from which it came. But simplicity is not the same as nothingness. The universe will have completed its work. It will have explored every possibility, from the birth of the first atom to the explosion of the last iron star. It will be a universe that has been fully lived. And we, in our tiny corner of time, were a part of that grand exploration. We were the part that noticed. We were the part that cared. And in a universe of iron and shadow, that is everything. So let the thought of the iron stars ground you. Let it remind you of the majesty of the cosmos and the fragility of our existence. Let it inspire you to seek out knowledge and to cherish the light. For though the end is written in the laws of physics, the middle is up to us. We are the authors of the current chapter, and it is a chapter full of fire, life, and wonder. Let us write it well, for the universe will never see anything like it again. We are the pinnacle of cosmic complexity, the highest point of the wave before it crashes onto the shore of eternity. And what a view it is from the top. In the end, the iron stars are not a symbol of death, but a symbol of persistence. They are matter refusing to give up, clinging to its existence through quantum tunneling and cold fusion for decillions of years. They are the final stand of the physical world. And if matter can persist for that long in the face of absolute cold and darkness, then surely we can find the strength to persist through our own brief lives. The universe is a resilient place, and we are its children. Let us live with the courage of the iron stars and the brilliance of the suns that came before them. The darkness is coming, but for now, the light is ours. Let us make it count.